The last problem asks you to solve a system of equations. So here's two equations. 3x minus 2y equals 10, x plus y equals negative 3. We want to find the solution of this system. Should I add the first and second equation together? Should I multiply the first equation by 2? Should I multiply the second equation by 2? Should I subtract the second equation from the first? Or should I divide the first equation by 3? This is another example where actually any one of these 5 steps is not wrong. But one out of these 5 steps is the most effective way to get closer to the solution that you're looking for. So what do you think? So 4 was the plurality and 3 was in second place. All right, so somebody that said 4. Why are you choosing to subtract the second equation from the first? To eliminate the variables. Right, so that's a very good priority. We want to try and turn this from a 2-variable problem down into a 1-variable problem, so that then we have tools to solve. So let's try it. If I subtract the second equation from the first, then I'm subtracting 3x minus x, which is going to give me how many x? 2x. 2x. And then negative 2y minus y is going to give me
Negative 1.
Negative 2 minus 1. Actually, it's going to take me down to negative 3. And then 10 minus negative 3, ample opportunities to mess up signs here, is 10 plus positive 3. And so then I get this equation, 2x minus 3y equals 13. Why am I going to contend this was not a very effective first step?
Because the y is not eliminated.
I haven't eliminated the y, I haven't eliminated the x. I still have both my variables at the end of this process. So while it wasn't wrong, we could take this green equation here and combine it with any one of the equations on the top and get a new system that has the same solutions as the old. It hasn't actually made any progress. It hasn't advanced the ball toward the goal.
Why did you get 3y?
If I claim that subtracting the equations from the get-go is not the most effective strategy, why did you choose, those of you who chose part 3, multiplying the second equation by 2, why is that a good idea?
Because the first one's already an opposite.
Uh-huh.
So multiplying it by 2 is going to be minus 2y plus 2y.
Yeah, so if I multiply the second equation by 2, what's going to happen is I'm going to discover that my y's have equal and opposite coefficients. So if I multiply the second equation by 2, it'll become 2x plus 2y equals negative 6. And why is that a good thing?
Because the y is
You're eliminating one of the variables.
Right, now I'm set up in such a way that I can eliminate one of the variables. What would I have to do now to eliminate, well, which variable am I going to eliminate? I'm going to eliminate the y's because they have equal and opposite coefficients. And how do I actually do that? How do I carry it out? Yes. Add these equations together, which adding is always a little easier than subtracting, at least when it comes to screwing up negative signs. So 3x plus 2x is going to give me 5x. Negative 2y plus 2y, 0y, which means no y's at all. And then 10 minus 6 will give me 4. And now I actually have succeeded in eliminating a y, eliminating a variable, which means I can solve this equation for x. What's my step? What do I do to solve this equation for x?
Just divide by 5.
Divide by 5. On the left and on the right. So I'll find out that x is equal to 4/5. By the way, once I find out that x is equal to 4/5, what else do I have to do before I've finished solving this problem?
Solve for y.
Yes, don't forget to solve for y. Don't get so wrapped up in your success in finding one of the variables that you forget to also find the value of the other. But the hardest step in a system of equations is getting rid of one of the variables in some way. And to do that in this case, the most effective first step is to multiply that second equation by 2 to make the coefficients of y equal and opposite.